Today we are going to use exploratory 3D analysis to quickly find water retention areas. These tools are great for quickly scouting out a new location. Let's get into it. Alright, so to do 3D analysis, we first have to set up a 3D scene. What you can do is you can just start with a local scene for a new project in ArcGIS Pro, or you can start with map and convert it after you have it set up. I'll start with a map and convert it just to show you how that's done. With LiDAR and other features, what you can do is you can go up into the view ribbon and click convert. What you want to do is you want to convert it to a local scene. And once you do that, you'll realize you are in a 3D scene. So in your contents tab, you'll now have 3D layers, 2D layers, and elevation surfaces. Currently, the elevation surface is using the World Elevation 3D, Terrain 3D, but what we would like to use is the LiDAR instead. So what we have to do is right-click on ground and add an elevation source layer. Navigate to the LiDAR raster for your area and hit OK. So let's show an example of how this looks. If we zoom in on an area, we'll begin to see that it really is a 3D surface. When you're working in a flatter area, it can be a bit hard to tell. One thing you can do is you can also exaggerate the elevation. If you click on ground, you'll get a new ribbon for elevation surface layer. You can do vertical exaggeration. And now the elevation changes will be exaggerated by the factor that you set. A word of caution, this also changes the calculations. So if you're using a vertical exaggeration of 5, when you're calculating the water retention capacity of an area, it will also be exaggerated by 5. One of my favorite symbologies for exploring in 3D is under Classify, using a random color setup, and then breaking it up into equal intervals. And then if you break it up into 256, which is the maximum amount that you can break it up, you'll end up with a pretty good way of observing landscape. So now when we look at an area, we can kind of tell that something like this, especially right around here, is pretty flat with steep walls. You can tell it's flat because it has a fairly long area of one color, while the sides change fairly rapidly. My guess is that depending on the land use, this would be a pretty good place to put in a retention structure. We turn off the LiDAR, we can see that it might be right next to a livestock operation as well. This brings us into exploratory 3D analysis. These are awesome quick tools to explore your area. We use the cut and fill tool. You'll get this tab pop up. Using an interactive polygon, we can map out the area that we want to check out. And then using this arrow, we can raise and lower the surface, and this will change the statistics shown on the left. We can also adjust the top height using this Z window. Let's bring the surface area down to about ground level. It looks like the ground level is around 417 meters above sea level. If we wanted a retention structure to retain about 1 meter of water, we can see how far back that would flood the area. Over on the left, we can also see the fill volume. With 3,000 meters cubed, we have 3.3 dams of water retention. If we wanted the water level to be 2 meters at the dam, we would end up with 16 dams of water. We can also turn off the LiDAR to see how it affects the livestock operation, which is now partially underwater. Perhaps not the best location. Also, this imagery might not be perfect. At about 419 meters, or at about a 4.5 foot water level at the dam, it might not actually flood out the area and provide about 8 dams of water retention. The other thing we could do is we could also just move this structure down to see how it works at a lower area. Going around, we can look for more water retention areas. An area like this looks like it could be a possible water retention area because it looks like it may be fairly wet land that maybe the landowner is willing to use for water retention. For example, ground level at this point is about 438.1 meters. We add only 1 meter of water on top of that, we end up with 13.5 dams of water retention. If we make that 1.5 meters, we end up with 48 dams of water retention. However, this might be a hard sell to a landowner as they might crop this fairly regularly. Perhaps an area like this, which is largely grassed in this area, and this might be already a pretty wet area, you might be able to work out something with the landowner. If you want to save the shape and the data around it, what you can do is head over to your Exploratory Analysis tab, click on the 3 lines, and convert to features. You'll have to create a new feature class or select one that you've already made, and then provide a description. This will end up in your 3D layers, so if you turn off your exploratory analysis, you can now see the shapefile. Going back into exploratory 3D analysis, you can head over to the elevation profile. Using interactive placement, we can select points along our line, and it will very quickly show us an elevation profile. If you head over to your Geo database, you can also add in a new feature class that is a 3D object. Let's create a new 3D object called dams. You can then start mapping out an area for a dam. Stay tuned for my next video where I will go into the hydrology tools to allow you to determine the exact size of the watershed and where that water is coming from. Thanks and see you next time.